It is my pleasure to introduce Areej Al-Wabil, who is an associate professor at the College of Engineering at Al-Faisal University and the director of Al-Faisal's AI Research Center and the Human Computer Interaction (HCI) Design Lab, which is a multidisciplinary research and development center specializing in emerging technologies. Her human-centered approach to developing emerging AI technologies focus on improving everyday workflows and quality of life by augmenting human abilities. From brain sensing to eye tracking and mixed reality, the AI Center's award-winning technologies are changing the way people with disabilities work, live, and learn. Through such experience, she has developed a deep knowledge of trends in emerging technologies, innovation ecosystems, medtech, intellectual property or IP, creation, and intellectual property commercialization. Towards that end, Dr. Rish served in the role of Executive Director of Intellectual Property Enablement at the Saudi Arabian Authority for Intellectual Property in 2019 and led the team which spearheaded Saudi Arabia's network for WIPO's Technology and Innovation Support Centers across universities and industry in the kingdom. Prior to that, she completed her postdoc training at MIT's Ideation Lab in the School of Engineering as an Ibn Khaldun Fellow and was an honorary fellow at the University of Kent School of Engineering and Design. Before we get started, I would like to request those of you who may want to ask Professor Al-Wabil any questions, as I'm sure you will, to please save them until the last 15 minutes of her workshop, as she has dedicated this specific time for a question and answer session. She will also be going through several activities throughout her interactive workshop that will allow you to actively engage through the chat function on Zoom, so I encourage you to participate. And with that being said, thank you so much, Professor Al-Wabil, for joining us, and the stage is yours.
All right. Well, thank you very much, Isha, and welcome everyone. I'm very excited to share this workshop with all participants, and it has been a vibrant day, a wonderful program of speakers, and I do hope that this workshop also complements the diverse topics that were covered in today's program and in yesterday's presentations and lectures. Now, this is a hands-on workshop, so there will be some activities, as Isha mentioned, and I'll be switching between the slides and some resources that we'll explore together. What I do promise is that it's not heavy on coding, so we won't be doing any development. However, we will be introducing you to some of the platforms. Now, before we start, I just want to make sure, because I have multiple screens open, a visual check with Isha. So is the screen maximized on the title page?
Yes, it is.
Okay, very good. All right, everyone. So the workshop's scope, the topic is reality engines, and we're looking at virtual reality, augmented reality, and mixed reality. And what I will be starting with is a general overview of the scope of work in the digital realm with a little bit of history in looking at how technologies and tools evolved in the past 4 or 5 decades. So the applied context will be art. So many of the examples that we'll be sharing will be in the context of creative works and artistic expression. And we'll look at how these technologies have been designed for all senses, the visual, the auditory, and the tactile. So there's a lot of interesting and fascinating work in these domains, and we'll touch on the input and the output and the processing that goes on in such systems. So the digitization that we're all experiencing has transformed our societies, but what we are sensing in this phase of technology development is that the realm in which we live is unrecognizable when we compare it to a few decades ago, in that the interactions are different. The insights that we can gain from people interacting with medium is at a level that has not been feasible given the technologies a few years back. So the potential for technology to enhance the user experience in physical and digital worlds has enabled the participants in this domain to propose different ways of interacting, and this is what we will explore together. Now, the technology advances, the two advances that were key to the development in this field are mainly wireless connections. Once technology became untethered, it became more viable for interactive environments or immersive environments to be available to users in their homes, in their schools, and other public spaces. Another advance is the computational power, the processing power of the visual realm or the auditory data sets that are, or streams, data streams that are required to create the illusion of being immersed in virtual environments have advanced where it can be packed within headsets, whether it's tethered or untethered. So these two advances have led to a proliferation in the solutions or the creative works that we are seeing in these domains. Now, the scope of the workshop mainly is to focus on reality engines, and that is to introduce some of the tools that could be considered for artistic expression, which is aligned with the scope of the SAAI hackathon or the SAAI Factory that we're all engaged in. So we will be looking at two of the leading reality engines, Unreal and Unity, and then we'll look at the OpenXR platform and how those tools can be considered, or the platforms can be embedded in the systems that you might be creating. Sorry, I don't see the screen changing. So let me make sure that the screen that is visible here on Zoom, yes, this was the workshop scope that I was describing. And at the moment we are looking at the topics. So the learning objectives, basically, or the topics that we're covering here is the different types of extended reality. So we'll look at the physical virtual continuum from augmented reality all the way to extended reality. And we look at the terminology just to make sure we're on the same page when we refer to these technologies. And then we'll zoom into the reality engines. We'll take a look at the learning resources and the tools, and we'll also have a reflection point in the workshop in which we look at the pros and cons of each platform. If you are undecided and not sure which one is right for you, we will discuss that a midpoint throughout this workshop, and then we'll look at the OpenXR platform. We'll close with a few use cases, perhaps to spark interest or inspire you if you haven't consider the virtual realm as a medium for artistic expression or for engaging with your audience, so that you can understand how these technologies have been applied by others in the 4 areas or domains that we have in SAAI. And these are motion movement, images, pictures, text, language, audio, and sound. All right, so we were looking at the history of art and technology and how the tools have evolved over time. And with the new tools being introduced, artists usually embrace the tools and explore different mediums and different ways of showcasing their work for audiences. The transition that we're seeing with extended reality is that the roles have changed, and that audiences are embraced or walk into the artwork or explore it in a different way. So the tools we use for creative expression have evolved, but also the experiences of the artists and audiences have also changed in the ways that art is being brought into the digital realm. Now, if we roll back in history and look at digital art as a concept, there has been a different definition in what constitutes a digital piece of work. But to make sure that also we are aligned in how we refer to this medium, we wanted to start with some terminology in that if we look at the past few decades, it was basically an expression in the digital medium of creative works. So the artists were using the digital medium or the algorithmic creation to express some form of art, whether it is visual or auditory or even language-based. In some cases, it was transitioning and showcasing the artwork in the digital form. So in the early years, it wasn't just technology as a tool, but it was more of using the digital technology as a medium to create and showcase and engage. But the engagement was limited to the interfaces or the GUIs, the graphical user interfaces that were available at that time, if we look at a decade or more ago. The engagement increased with the availability of more immersive experiences. So if we look at this exhibit, and the audience can also visit the website, we'll share the slide deck that describes the rules, codes, and choreographies in art that looked at it in a span of 50 years. It looked at the effect of digital media, how it has enabled artists to express in a different form or to reach audiences that were otherwise inaccessible. So art became more accessible, but also new forms of art emerged with the medium being accessible and available to artists. So some artists were engaged in the actual coding, whereas others used the tools that interfaced with the backend coding that is required for such creations. This exhibit drew on the historical connection between the conceptual video and contemporary digital art that was not immediately obvious. There are similar exhibits that also reflected on the intersection between art and technology. Now we're zooming in closer to the relevant topic of assets in extended reality applications, and this takes us to the digital realm of pixel art. Pixel art started with the limitation and constraints that designers and developers had with the machines at that time, the 80s, the 90s, even before the internet, in which the limitation on the computational power and the graphic interfaces limited what could be drawn, what could be rendered on the screen. So you can see here how it evolved over time. And then there was the slow downfall from the 80s and the 90s. It was growing in popularity. And then the downfall of pixel art as more powerful gaming engines evolved, were introduced and emerged. The design transitioned to more to rich visuals. And it has always been a captivating prospect for designers and developers. So it started as a workaround for technical limitations of the machines at that time. It was utilized, refined to the point that it was ubiquitous in the gaming culture in general. Now, the highs and lows that it faced eventually resulted in developers using pixel art in some cases as an artistic choice instead of a shortcut for primitive or limitations in the technologies that they had available. So if we look at now the concept of digital art, not limited to the pixel art, and these are the digital born art creations that were created, stored, and distributed via digital technologies. This is what we see in our current times. Examples are the Beeple NFT, the art creations that are used or shared as what we call them assets in the digital marketplaces that are linked to the reality engines. And then there are the creations of the digital creations and the scope of work that looks into the preservation of that type of digital form and the distribution, the context of sharing and distributing such artworks. Now, what we are witnessing in recent years is the features are evolving to bring the art closer to the audiences and also engage the audiences with the artwork. So while all these characteristics are not are exclusive to digital art in terms of the interaction design, they are also seen in other art forms such as the performative events or video art. So they're not intrinsic elements of objects such as the static artworks in which the user needs to be present in a space to experience them. So the design of such experiences does require catering to all the senses, the visual, the auditory, and the tactile. So these installations have the option of designing for real-time interaction. It could be interactive, even if it is not synchronized. It could be process-oriented, and in some cases performative, where the users are interacting and influence what is being seen and what is being experienced in such contexts. So if we recap here with the transition that we are highlighting in how design has changed or how the design of such technologies has evolved, we have looked at the expansion in the range of artistic practices. From advancing the concepts originally explored in conceptual art or art in general to generating new realms, these are the virtual worlds or new mediums in which the user can interact, from the visual, auditory, tactile, even olfactory, and the sense of smell in the way users experience digital worlds or virtual worlds. Okay, so now as we move on here, there seems to be lag, but let me make sure we're on the same page. Okay, so the point here is that the traditional notions of artwork, audiences, and the artist have changed, and in designing such experiences, empowers the artist to expand the scope of what could be shared or presented in a different way. Audiences also have the experience to explore what is relevant or to follow their curiosity and understand it from their own perspective. If the information is layered or the artwork is layered, and they can explore it in different narratives or in different modes, which the technology actually affords and facilitates. So the artwork itself is transformed. It's usually open structure, and the process of showcasing, capturing it, showcasing it, and making it accessible relies on the flux of information. Now, when we say information, we're referring to the data streams, the visual, the auditory, and even the language or movement. And we'll take a look at that embodied in a few examples that we'll explore together. Now, it's very much similar to performance, and the way a performance is designed to engage with audiences, but in some cases here you could rewind, you can capture and re-explore the medium in different ways, which is often not afforded by the static performance type of context. Okay, so the audience becomes a participant rather than a viewer or an explorer of a collection, in that in some experiences you can allow the users to reassemble the creative work, the textual, the visual, the oral. In some cases, even the tactile. You might have an interactive experience where you would have tactile feedback from worn elements, let's say gloves or worn pieces or vibrations, and then the user could redesign the experience so that it's aligned with the sensations that they would like to experience in that visit or exploration for a collection. Now, the activity we're going to do together is one of the advances that facilitated the development of extended reality experiences. So we'll start with 360 videos and how that changed how audiences experience art, but also how audiences can be pulled into artistic creations. So if we look at that, we are going to take a look at a few examples before we actually visit a collection together. So let's start in thinking about augmented reality, and it is one of the four types that we'll look at together in the second part of the workshop. So with augmented reality, it's having digital objects or digital designs overlaid in the physical world, so you can actually see and explore and move around with a device, whether it's a tablet or a mobile phone, and then see these objects that present more visuals or more elements to the physical space that you would be in. So imagine using the mobile phone to either look at a collection that's already created, or some objects could be pulled into the space that you are actually in. So you can visit virtual spaces, or you can have these spaces come to you. Another experience would be virtual reality, and that is where you are transported to a virtual space in which collections or artwork is being showcased and displayed. And this is one example of the Google Art example. This is the Sao Paulo in Brazil museum, in which you can explore different pieces as you virtually move around the space. Another example are the digital assets and the level, the high resolution that they can be displayed in. A few years back, it was limited to the bandwidth that we had and the computational power of the machines that are available in the consumer product market, from mobile devices to laptops or desktop machines. At the moment, we're seeing high resolution images being rendered in a very simple or a typical laptop, an average laptop. So one collection is the collection that we have in this museum in Peking, Beijing, in which the high resolution of the artifacts could be explored by the visitors. In some cases, we do have virtuality vary. You might have a full exploration of the physical space with the artifacts zooming in, either in augmented form or simply layers of screens, or in other cases, it might be a walkthrough, and you would have layers of information available where you can click and explore. So some cases are digital copies of real works of art, and others are artworks that are created in the digital realm. So it doesn't really exist in the physical world. It doesn't have a physical embodiment. However, users are, or audiences are invited to explore such realms. Or collections. Another way to look at it, if it's viewed in 2D or experienced in 3 dimensions, and that's something we'll dive deeper in the second part of the workshop, because when we look at the transition in graphic user interface, for the past 3 decades, designers and developers have been mainly, or the mainstream applications were for mobile applications or mainly screen applications, and that's 2D environments on a 2D space, or 3D environments rendered on a flat 2D surface. However, right now, with extended reality technologies, we have the opportunity to have the audience or the visitor or the user actually immersed in a 3D world. So we're designing for a 360-degree or 3D space in which all angles need to be designed, made available for the user, so that if they turn right or left, that also is aligned with what they see in the screen or on their devices. Now let me make sure that we're also aligned with the slide. We're on slide 21. Okay, so the audience and the artists, curators, auctioneers also have increased their digital footprint. We can see from the emerging technologies and what is being introduced to audiences is the experience of the visit, but also the experience of creating it or even adapting it in some of the creation. So it is no longer a one-way bandwidth, it's a two-way interaction mode between the creators and the audiences.
Break.
Now, I'm sorry, go ahead.
Sorry, I thought I was muted. My Zoom crashed. Sorry about that.
Oh, no worries, no worries. All right, so the activity, let's do this activity together. So I'm sure that with everyone with us here in the virtually in the Zoom, we do have around 20 plus. So we're going to visit one of the art museums in Estonia that did an amazing job in the 360 rendering of their exhibits. We're going to visit one exhibit in particular with 360 video. It means that it was captured so that the full view of the space is captured and made available to the users. And we have seen that in videos that are displayed on our mobile devices, laptops, in which you can have a full 360 view, even if you're not wearing any head-mounted display. So this is one example. If we look at the exhibit, we're going to visit one specific exhibit together, and I can conduct a walkthrough on my machine, but let me share the link with all of you. And yeah. So this is an exhibit. It's called Violence Grows in Silence. Let me just share the link here. Okay, so I'll be sharing the link on the chat. Let's see if it works. Yeah, once you click the link, let me see if okay, I'm switching my screen. Now, if you visit the exhibit, you can, okay, it's rendering slow, but let me guide you. If your machine is faster, it's perhaps the bandwidth. I will show you the two fixed screens. So with the link, you will find an exhibit that's listed as Violence Grows in Silence. We could spend 5 minutes in looking at the exhibit. The concept is highlighting domestic violence, and it was basically presented to users in the physical space as a collection of dead plants that were donated by the community that came together in this exhibit. And you would have to navigate. It was intentionally made difficult to navigate in the physical world. So when you explore the space, you have these points, the white points, in which you can turn right and left, and then there's a flight of stairs. So if you had access now to the exhibit, I would encourage you to navigate between the trees and then go up the stairs, and what you will find virtual avatars seated watching the video that highlights the voices of individuals that describe their experience of domestic violence. So it was building up, it was designed to build the experience so that whether the visitors, the audience, were on site in the museum or visiting the virtual exhibit, they would experience that complexity navigation first, and then they would have access to the video that attracts and sustains their attention as they watch the experience. So I'm at the point where I'm walking up the stairs. Let me make sure that the Zoom screen is also showing this. Yes. So as you go up the stairs, you have access to the video that's showing, and then you can see the heads of the virtual viewers that are also embedded in this experience. All right, so I'll be switching back screens. I'll turn the screen off, and I'll be jumping back to the slides to give everyone a chance to experience it. I can provide a little bit of commentary as you are experiencing this exhibit. Keep note of the videos, because once we look at reality engines, we'll look at how these digital assets basically are created. They could be built from scratch, or they could be video capture. So much of what you see in this exhibit is realistic, so it's real video. However, you do have assets embedded virtual to create that experience for the users. So the experience here is that once you enter the big hall, the visitor is confronted with a work that prevents you from wandering around. So it does block the easy access. The plants were placed there for a specific reason, so that they're spread over the floor, and you encounter these plants that are barely alive and mostly dead. And it's often basically an expression of how these domestic environments would be, in that they lack the nurture and care that is needed for these plants to grow and be lively. So the accumulation of plants would introduce you to the show that is accessed once you climb the stairs. All right. Now, the underlying methodology, the artist here is Flo Casaru. Her artistic practice is abstracting and then recontextualizing the everyday objects that we see here, from the plants and the items that are often found in households. So the artist wittily changes the meaning in order to formulate a social critique, and in this case, the topic of domestic violence. All right, now let me jump to the question that I see in the chat from Tas. What are good digital software to create digital art? We are going to look at that in the reality engines, because with every engine, it is often in the tech stack compatible with digital art platforms, and we'll go through that in a moment. All right, so mainly we're zooming into Unity and Unreal. So let me do a quick check with everyone that is participating. If we're good to go, we can move on to the next topic. Let me make sure, Isha, just to make sure that we're on the transition slide of what is extended reality, which is on point with the question that was presented.
Yes, we are. Thank you.
Wonderful, wonderful. Okay, well, thank you so much for that. With the activity, I'm hoping you got an insight into the type of medium that could be presented to users. And keep in mind, you experience this with a flat screen, whether you're following this workshop on a mobile device or on a laptop. However, the experience would be much different if it's a purely virtual world and you are transported with a head-mounted display to the experience, in which you can hear, see, sometimes touch and taste and feel some interactions that add realism to the experience. All right, we'll start with a few definitions. Now, what we looked at a few moments ago are different examples of augmented and virtual reality. And what we have is basically the three basic types, where augmented reality is the real world and the virtual elements are overlaid in the space or environment that we are in physically. In a virtual world, the user is immersed into a virtual space in which the digital objects could be realistic. So realism could be achieved with the design of such environments, or they would be designed to actually present the illusion of being transported to a different world that is far from what we experience in the physical world that we live in. So it's a virtual immersion into a simulation, and it could be designed in different ways for all senses: the visual, the auditory, tactile, and in some cases olfaction, and that's the sense of smell. Mixed reality is we have a combination of both. So you would have semi-transparent, so the headset does not block your view from the physical space that you're in. And then you also have the digital objects overlaid in this physical space. The difference here is that you can interact with these virtual objects. And an example would be if I had a cup of coffee and it is a virtual mug in a physical space. So when I place the mug on a table, the physical table, the laws of physics apply and the mug would be resting on the table. The virtual mug would be resting on the physical table. That's just one example of how mixed reality can combine the features of different objects and blend them together in the way we interact, move, or push and pull, or all the affordances that we have in human-computer interaction. Okay. So the continuum is one of the basic concepts that we always introduce to designers and developers so that we understand in which realm we're designing and developing. So we often move from the experiences of what we know as the real environment to either augmented reality, and that's adding virtual objects to the physical space, augmented reality or augmented virtual reality, where you have real objects projected and controlled in a virtual world, and that's where mixed reality is often best fit. And then you have the virtual reality where the user is transported to the virtual space or the virtual world. Now, the emergence of these type of technologies was mainly in the past 5 to 6 years. So from 2014, we have seen the immersive and extended technologies advance and become more mainstream because of the advances in hardware and software that made it possible to have the streams of data transmitted to the user, individual user, so that they can experience it, experience virtual worlds, and also it caters to multiple senses where the technologies sensor-based technologies were not advanced at that time to be integrated with the headsets more than a decade back. So when we look at the different technologies, how they came together was mainly 5 years ago, where we saw the streamlined compatibility cross-device in which you can design a software, develop the code for the designing an experience and simply plug in the different sensors, plug in different platforms or connect to different platforms, and then deploy in a seamless experience for users. One example that we just experienced in the activity was a 360 video. So you can actually have a full view. You're not limited to the field of view of what we see on a flat screen, so that the media in itself in the virtual world, it's either designed with 360 or actually captured. So if it's a realistic experience, then the video is actually captured in that way. You can design a VR environment, and that's the virtual world, the 3D environment in which people can walk, manipulate objects, and move and interact with others. The interaction with others raises the complexity to the next level. So if there is human-to-human interaction in the virtual world, where it's not with an avatar, then it adds complexity, and many of the computer science or the HCI problems are still unsolved here in terms of conversation design and also interaction, because humans with objects, we know the laws of physics and how to interact with these objects, what to hold, what to place, what's the affordance of these objects. But when it comes to human interaction, it's difficult for machines to anticipate. And this is where AI comes in, of what a person can be doing, can be saying, what to capture, and how to design for that type of interaction. In augmented reality, 3D content is overlaid And we have seen that early on from the Pokemon game that introduced it to the mainstream, to more advanced experiences that we're seeing now. Now we do have, yes, a 360 video in which you can experience it. This is the second activity. So let me have, it's bit.ly SAAI video. Let me share that also in the chat. Here we go. It's a shortened video in which, because the experience that you see here in the video that I'm showing will be different when you experience it on your own device. So to make it easier for you to choose and explore, so choose your own experience. You can look at any direction. So I'll be turning to the right. So of course, this isn't, this isn't a realistic experience, it's rendered. But if you visit the video itself, yep, you can explore the sky, you can look at different directions, because the virtual space was designed to allow for such navigation. Of course, it's muted here so that you all get the experience of listening to the audio on your side and also exploring the video. Now you can imagine how these virtual worlds or virtual spaces could be created if you do have a creative work in mind in which you want to invite the audience in. It could be abstract, it could be realism, and also look at the tension between realism and abstract or simplified designs, because realism is very expensive in terms of computational power, and that's a design decision that artists would make. More examples here are in this website. So it's artsandculture.google. You can take a look at more 360 videos. So I think we're going to go through a quick interactive quiz, but before we do that, let's take a look at how XR adoption has been observed. Basically, in the context of art, we've seen it in museums showing their curated collections, and in artistic expression in which the artwork is basically created in the digital medium and shared with users. The tools, this is to answer Tas's question that was posted a few moments ago. So there are the 3D modeling tools that are well known in the design community, such as Maya and Blender and others, but also there are tools in which you can create in VR, because that eliminates the complexity of designing 3D on a 2D or flat surface. So stepping into the virtual environment allows you to focus on the creation itself rather than the technical side of designing 3D. So the tools that we are looking at here are just a few examples of many that have been introduced to facilitate the creation of 3D art without the knowledge or understanding of how 3D modeling works. So it eliminates the learning curve or the barrier to entry to such creations. One example is Tiltbrush, and you can visit tiltbrush.com and we'll look at both Tiltbrush and Quill. Let me make sure here that this is muted. So what you see here is an example of how Tiltbrush was introduced to artists. This was the Google Cultural Institute, and it was introduced to the artists to see their first impression in that tool and how that could facilitate their process in creating digital art. And what we have seen, or what research has shown, is that once the artist steps into the virtual world, the creation process becomes more of the focus on the creation itself rather than tweaking the technical details to have it aligned with their vision, or addressing the glitches or the limitations that the platform presents to them. And this is where the creation was taken to the next level. And as you can see from this video and many more, if you search online to feedback on TiltBrush, in that it did facilitate not only the creation, but also for them to reflect and tweak it in a much easier way. For any of the audience members who are familiar with 3D modeling and graphics, it's a tedious process in which tweaking the images would require some technical background, in some case, some mathematical modeling. Another example is Quill. It's a VR illustration animation tool, and you can see here again the video is running, and I'll just briefly describe how this tool also helps with creation animation. You can create the assets and then you animate them, you create the scene, so you do have this visual world created, and it can be deployed either on flat screens 2D, so it appears 3D on a flat screen, or deployed onto HMDs, and these are the head-mounted display, in which the virtual world and the objects inside this world, in what we refer to as assets, are merged into a virtual experience, and the user or the audience is invited to enter this virtual world, and they can actually experience it in whatever the designer created. And what they see, what they hear, and sometimes the wind blowing or what they feel in terms of tactile could all be embedded in such experiences. So this is another example. The tool is designed to be expressive and also precise in the way the animation is designed. Once the navigation and the type of manipulation is identified, it just becomes a matter of running the code and deploying on the device, whether it's flat screen or 3D immersive experience. All right, so now we're transitioning to the engines. What we saw are the platforms or tools that could help designers either capture realistic views, and that was the example of the 360 videos, or help you as artists or creators to look at how to create assets or digital assets. And these are the objects that could be embedded in the virtual world, or could be actually the work of art that the audience would be invited to explore in the virtual realm. Yes, so before we look at the engines, a quick quiz. So we're going to go through the mapping. I just want to make sure that the audience here is following in terms of mapping the types of XR in extended reality. So if we look at this popular overlay that Jeff Koons created, so the sculptures by this artist were made available to audiences that are geographically in close proximity to some monuments across the world. We had Central Park in New York, Sydney Opera House in Australia, and the Eiffel Tower in Paris. So with this experience, the question is, what type of XR do you think the sculptures here would be mapped to? Is this virtual, augmented, or mixed reality? So the question is it VR, AR, or MR? You can type in your answer in the chat window. Okay, I don't see any response in the chat window. Thank you, Michael. So one answer is augmented reality. The concept here, yes. Okay, so I'm seeing 2 responses, and both of you are correct. It is AR. In that the sculptures were overlaid over the scene, so a person can take a photo or a video and capture that a augmented reality. Now take a look at this music video in which what you have here is you're listening to music, but you're also being transformed into a virtual space in which you are looking at different objects and also other people that are wearing head-mounted displays and listening to the music. Let me see if I can share the audio here. Okay, so you can watch the video in full. You can look up Square Pusher, but in this example, what type of extended reality did the Square Pusher team use in the music video? Now, of course, none of you were wearing the head-mounted display. It was displayed again on a flat screen. But do you think it's VR, AR, or MR? Thank you, Julia. So one answer is VR, MR. So Arnab, it could be MR if the digital objects are overlaid in the physical world. I'm not sure this video actually implements that, but if it had that added feature, then it would fit with mixed reality. But it's closer to VR as noted here by Julia and Michael. Thank you all for the response. So mixed reality is just a version above in that a level above in terms of implementation, and that the virtual experience is also it also involves that the digital objects exist in the physical synthetic world. So the head-mounted display is often semi-transparent rather than having it transparent or blocked. Okay, so here's another example. Acute Art created these objects that could be projected in the context of where the person launched the application, whether they're in public spaces, at home. So it showcases works from artist studios and it's displayed by the user's personal device. So again, what type of XR did Acute Art use in that example? Quick question. So is this virtual augmented reality? So virtual means you took the user and transported them to a virtual space. Augmented, you brought the digital objects to the physical space of the audience. Mixed reality, you have a combination of both. There is the virtual world, but you also have the physical space intact, and you can interact in that the digital objects interact with the physical world. All right, so the work here is Acute Art. You can actually visit the website's app. Let me copy the link. It's app.acuteart.com. It is closer to MR if you actually had the headset or AR. So yes, it is actually AR. It's augmented reality. Now, if someone is wearing a headset, however, on their website, they did not make it, they didn't disclose if it's made available on mixed reality headsets such as Magic Leap or HoloLens, but it is closer to AR. All right, now that we have these three terms clear, we will be jumping into the topic of reality engines. But what we saw here were three examples in this quick quiz, and thank you all for taking part. We looked at how the different types of extended reality actually expand the scope of what an artist could create and make available to different audiences. It also expands the scope of what audiences could do in the digital realm, whether they step into it fully, as we saw in the virtual reality, or they actually bring in the artworks in their synthetic world. And that's what we saw in the mixed reality or augmented reality. So we're seeing this, the advances in XR making the artwork more accessible, but also the interaction design that was not feasible a decade ago right now, very much seamless when users are transported to these art experiences or creations. All right, so the advances, we don't see it slowing down. This is just the industry before we look into the technical details, because what we are seeing is that the community is growing, the technology is becoming more accessible. It is driven mainly by the gaming industry, interestingly, because of the massive market that the gaming industry has in terms of the immersive experiences for gamers, and much of that has been applied to different contexts in training, learning, and in this context, artistic creation. So we do see that as an advantage, and the virtual spaces are becoming more creative, and we're seeing different experiences being captured, from volumetric capture to the different audio capture and how that is rendered, as we see here with the SAAI, the AI-enabled or AI-driven technologies in the way the capture is optimized, but also the rendering of such experiences is becoming more streamlined. So this is a prediction to what could also be made available, or what what is the projection that we see in terms of the platforms that we just took a quick look at. You can see that the experience of how audiences see art or touch art or experience art would be elevated, in that they can see, hear, in without having the limitation or the constraint of being in the physical space, allows them to explore it in their own way, or also gather information in a more streamlined way. From the artist's perspective, they can expand what could be created in the digital world to create different experiences with an object that they envisioned. And we're going to see that in a few moments in the reality engines. All right, so with that, we will go for a very short break, 5 minutes. Welcome back, everyone. This is the second part of the workshop, and this is a bit more technical. What we looked at in the first part were the types of extended reality technologies, and we experienced a few of the examples for 360 videos, and also we looked at some of the tools that artists or creators could consider in virtual spaces or designing virtual worlds. So what we are going to do here is a quick recap, and then we'll look at the leading reality engines. So to recap, the types of XR technologies that we talked about and saw examples of were augmented reality. And this is where the reality is enhanced by having virtual elements in our synthetic world. Virtual reality is the other end of the spectrum, in which the audience is transported to the virtual space. It's fully digital, so you have the assets and you have the spaces designed so that the user or the audience is immersed in that environment. Mixed reality is in the middle. Basically, you have the physical and the synthetic objects coexisting, and you would apply the features of the virtual objects to the synthetic elements that you have in your environment. But you can also enhance the experience for users in that the semi-transparent headsets that they would have could also overlay information that's relevant to the experience in whatever way you would design. So having a look at now the types of technologies that could be designed, we look at the reality engines, because the idea is that reality engines are basically the platforms in which you can create assets, whether within the engine or import them from other 3D modeling platforms. And there are many out there. Maya, Blender are just two examples, and there are many more. And many of the reality platforms are compatible with these mainstream or well-known 3D modeling platforms. And then you would create the virtual world and design the experience. That's the third layer, because the interaction design is where the complexity lies in what are you designing for the users to be able to interact, how will they interact, what will be manipulated. So these features need to be designed and developed. Unity and Unreal are two well-known platforms for such creations. Unity is more technical. It's easier in terms of barrier to entry, more popular with the coders when compared to the artists, in which the preference would be Unreal. However, the barrier to entry in Unreal is a bit higher in terms of the graphics development. However, the quality is different, and we'll look at them side by side in a bit. So the key features that are relevant to artists that might be considering these tools, and also to answer the question from Tess when you were asking about what are the tools, Unity and Unreal, that we're seeing together with the tools that they have in these platforms would be the answer to your question. So with Unity, we're looking at AI-enabled features in materials themselves and selection of the material, having the realism designed and developed for the audiences requires some intelligence in what is embedded in the scene, the placement, how do you make it visible to the users, how do users interact with it, and also if there are sensory inputs or elements to the design in what they see, what they hear, what they touch, then that needs to be taken into consideration as well. So the tool or the feature within Unity is the art engine. It's AI-assisted artistry, basically automates the process so that the artists focus on the creation rather than building the algorithms or the modeling for such objects or such interactions. And this is where you can explore it under the product collection of Unity. And it basically, it has some coding involved. However, it is mainly a user interface in which click, drag and drop, set the features, and you can start creating the virtual space that you envision in your mind right away. So that's the art engine. The process for that, let me make sure the video is rolling. And Isha, do let me know if the screen is not showing the video. Here it is. So basically,
it's good.
Thank you. Thank you so much. So with the art engine, it goes through a process in that objects could be designed from scratch, embedded, or imported from other libraries. And the marketplace for assets are plenty. Each platform has its own community, own marketplace. So you can look up marketplace for digital assets that are compatible with Unity, or you simply scan the world. So the example of 360 videos that we started with was relevant because I wanted the participants in this workshop to experience how the actual physical world could be captured and visualized within the space. And then users or audiences are invited to join those virtual spaces. So in terms of data in the art engine, you can have a search for the data, scan, paint, and then it goes through the automation. You can enhance it, you can expand, you can transmit. And what happens is that when users manipulate the creation, their experience in that space might be very different from another person that entered that virtual world. So this individualized experience, or the bespoke experience, allows users to take the experience to the level where curiosity would lead them to a different experience in every visit, in every interaction with that object. And that is the beauty of extended reality, in that that experience could be captured. And not only that, the objective measures of what a person sees, feels, even the heartbeat, or if you have the right sensors, the anxiety level, the user's emotion could be inferred from what you see. You would have eye tracking, you can see their eyes, or you can see through their eyes, and the heat maps of what they see, what they touch, how they interact. And that rich data set could also be captured, exported, and looped back in designing the experience in a different way the next time that they visit that virtual space.
When you're creating content in
Now,
Unity, you can
let
typically
me
see
mute this as well. Another concern that we all often have is the barrier to entry is sometimes the hardware. So do we have a simulator? And these both platforms have simulators. So Unity allows the developers to actually explore it on a simulator, design a virtual world, and then explore it before it's deployed on a head-mounted display. So it does facilitate that type of testing, user testing before deployment. Now, the resources available, both of them have excellent libraries and learning paths from beginner, intermediate to advanced. And with Unity, they have a specific learning path for VR, AR, MR. So even if you are beginning in exploring this medium, it is something that could be mastered in 2 to 3 weeks in terms of the basic usage and deployment. So you can go from a digital creation to a deployed product in 2 to 3 weeks using Unity. It's free, accessible, and the learning path walks you through a project. So it's project-based learning. Unreal. Okay, so the next engine that is well known in the field is Unreal. Now, Unreal is optimized for extended reality. It is much more powerful. It's usually used by gaming studios and also in the film industry, or even high resolution creations in terms of audio, video, in installations or concerts. So it is optimized for extended reality. There is some fees, not all of it is as accessible as Unity is. You can explore what is available under Unreal through the unrealengine.com website. I'm just going to zoom into 2 features that might be relevant for the SAAI, and there's a wealth of information on their website. So one feature is geodata, so geospatial data. So if you have an experience in mind in which space or spatial interaction is relevant, then it does have seamless integration with these tools, as you can see here featured on the screen, and its strength here in MetaHumans. So creating human-like figures is something in the pipeline, in the XR creation pipeline with Unreal is just a matter of minutes in creating features and manipulating the features from different ages, different skin colors or ethnicities. It is realistic. So in terms of realism, very high, where it can be achieved in Unity, however, would require much more effort to achieve the humanoids or the human avatars. So if this is something that you are aiming to consider, then Unreal would be a more a viable option in terms of platform to develop a realistic experience. All right, so the learning resources similar to Unity, you have the design assets and spaces all available in terms of the pathways, the learning pathways. You can look at how you design 3D objects or model them, and then how do you create assets, embed them in your virtual spaces. and also looking at the design of virtual spaces, the lighting and all that goes, all the design aspects that go into what the user will be doing in these spaces, how they navigate, what are the affordances, what can they touch, what can they manipulate, and the interaction between different users, which adds complexity, but if that is part of the experience, then it can be designed and considered in your creation. Now, going back to the tension that is well known between realism and abstract drawings, simplified drawings, just so that the user is immersed in a virtual world, but it could be very realistic, and that comes with the computational complexity, or you can simplify the images because the experience offers different aspects, whether it's auditory or tactile senses, or even the visual would suffice in the way it is designed. It's a design decision, and many of the platforms afford both. So it usually depends on the context and the bandwidth that you have, the headsets or the hardware that is available to users. So Tess, I hope by now we have answered your question. In terms of the coding, this is the final platform in which with OpenXR, it's basically an augmented or virtual reality platform. It's a standard for developing for these platforms. And you can access OpenXR if you look at the Kronos Group Consortium and their resources. And what I wanted to highlight here is how OpenXR fits into the tech stack that we have in terms of different reality engines. So if you are using Unity, Unreal, or any other proprietary engine, and you are connecting, what you find is that with OpenXR is the application interface in which you can design a virtual experience, a virtual world, virtual assets, embed them, design the interaction with a vendor agnostic approach. And then you deploy basically on the headset. Sometimes it would require some tweaking, some libraries that are specific to that vendor. However, the OpenXR creates the standard that makes it much easier in terms of a cross-device type of design where you're designing one experience, but also deploying on multiple headsets. All right, so as a recap, this is what I promised you to reflect on before we move on to the use cases. And that is to take a look at the two options that could be considered for extended reality. If we have them side by side with pros and cons, we have Unreal and then Unity, and 5 different aspects in which we can compare them. The quality of the graphics, as I mentioned earlier, coders prefer Unity. It is known in the community, while others, artists, especially if they are tech savvy, are probably more in the first group. However, artists that have less exposure to different technology or coding would prefer Unreal because the barrier to entry there is much lower. The visuals are much quicker to render and deploy with Unreal. The material editor that we saw in Unreal and the AI-driven approach to creating these objects make it much easier. This does not mean that it can't be done in Unity. However, it does require more work to achieve it in Unity. You can also embed the Maya Blender products or any other platform. They're usually compatible with both Unreal and Unity. Now, in terms of features, AI and how well it is implemented, it is very much prevalent in Unreal Engine features when compared to Unity. Again, having said that, with Unity, you can have AI-driven models as part of the experience. Unity serves more of a user interface type of design, and then once you deploy, you can plug in the AI-driven modules. Target audience, Unity is popular among the independent developers, the indie community. Unreal is more aligned with the big studios, the gaming studios. However, the independent developers of extended reality experiences are embracing Unreal more and more these days. Now, in terms of coding, C is mainly C# is the language that is you deploy in Unity, with C++ being linked to Unreal, and this is one of the reasons where it's easier to find seasoned Unity developers when we compare it to the Unreal Engine. However, if you're in the tech community, in many cases, they're familiar with both languages. Now, in code editors, both of them have visual code editors. In some cases, it can plug into with the tech stack to other scripts that could be embedded in the objects, could be embedded in the interaction design. Community, both of them have thriving communities, so they're comparable in that regard. Okay, final check. I don't think that we would need another break, but we can break for 5 minutes if time allows. Yeah, I think if we can skip the break, would it be okay with everyone looking at the chat window to power through? We have a few use cases.
I think that's okay. I think we can continue.
Continue, okay. Thank you so much, Isha. All right, so extended reality at the intersection of AI and art, which is what we are experiencing with the SAAI hackathon or the SAAI Factory. And to spark the interest in considering extended reality or experimenting with these platforms, we're going to share with you a few use cases in all 4 categories: motion capture, language, picture, still images, and audio. Now, AI, how does it link to AI? As I mentioned before, with the sensors that we have, these headsets and these experiences, you can measure what people see, what they hear, tactile. And in addition to that, you can give the feedback to vibrations, let's say with tactile or motion senses or olfactory senses. They can hear when the oral architecture is designed, they can hear in 3D versus also not versus, but also enhancing the experience with just experiencing on a flat screen with their eyes the virtual space. So we are going to look at a few use cases that have a dual mission. They are, in these examples, they preserve and investigate art and medium and how that can be presented to the public for a specific purpose, whether it is to introduce art to a community that is not aware of it, so it's raising awareness, or to allow to make the art more accessible and allow users to manipulate part of the experiences. So that they experience it differently every time, or they see it from what is aligned with their curiosity. So we'll start with motion movement, and we'll take a look at one example here, and then one project that is also participating in SAAI. So this example that you see here with asphyxia, it's a fusion of dance and motion, in which they were experimenting with the motion capture using Connect. So it wasn't advanced mocap suits or advanced sensors. It was simple motion detection remotely, not mounted on the dancer. And these visuals were created to show how filmmaking could be done by capturing let's say incomplete information, then augmenting that with the information that would be rendered or merged and integrated in the computing side or in the virtual space. So the experience that inspired by that work, we do have traditional dance for indigenous populations or folklore dance local to the region. So we do have a team that's looking at with the Royal Institute for the Traditional Arts, the performing arts, and these are the motion that is being captured by these dance performances and recreating the experience so that users could be could have a closer look at the dance itself. And part of it is preserving these type of dances that are passed on from generation to generation, but also introducing the concept to learners who are interested or to audiences who want to learn more about the history. So we have different regions, 6 regions participating in the local hub with live performances of the dance and the engineers capturing the motion in different ways. So some with sensors, others with remote capture, and using AI-enabled algorithm to recreate these type of creations. Now, in terms of conceptualization, I wanted to share this example with Dust. It's from the group in the UK. You can visit the full exhibit from the website. It's vrdust.org.uk. It's similar in terms of the virtual reality piece. So visitors can experience the motion that is exhibited by the dancer through a headset. So it's a virtual reality headset. And let me jump to the next slide just so that you take a quick look at how it was created. So what you see here are the dancers and the motion captured remotely. So here they're not wearing the mocap suits. It's basically captured and then rendered. And basically with this exhibit, the purpose or the objective is to transform the way people see and experience contemporary dance. So it's an immersive reality experience. It explores the boundaries between virtual and the real world experience of audiences in such performance contexts, and advances research in the field of participatory performance, because you have the dancers in the space in which it's captured and the audience also in close proximity, but also it explores the human-computer interaction. How do we design the interaction in such experiences? And the VR technologies, because still with VR, we do have some challenges that are yet unsolved in terms of user experience, the motion sickness that users would experience in such visits or experiences of performance or artworks. Okay, so this we talked about image and picture. So in this, here's the example. We have one example of emotion. So emotion mirrors are basically experiences in which it can be virtual or augmented reality for passerbys. We do have walls in which the mirror would detect, the mirror would show users a reflection of them as they pass by. We have this on display on campus, and then users would be, the facial expression would be detected based on the mood, and they have emotion classification and then poetry visualized on the wall, Arabic poetry that is relevant to the emotion being captured. Now, what we're experimenting with is not only the facial expressions of passerbys, but also vocalization, not necessarily language processing, but vocalization, how words are said, or just the vocalization as people are moving across the space could indicate the emotion and the emotional status of the individual. And that's where the visualization would be with Arabic poetry aligned with those emotions. The third example for picture and image is not the still image or what's captured by video or still images of facial expressions or the audio. This is the art in the making. So basically, we have archives of more than 10 years of research in Al-Qat region. It's an art form that is exhibited in the interiors of homes in one region in the southern part of Saudi Arabia, and it is delegated to the women only in those tribes, and that the males would build the structures and the interiors would be created by the females in that context. It's one of the preserved heritage or recognized heritage art forms by the UNESCO. And what we're trying to do is digitize the archives of these arts as they are made. Even the colors are made from local local plants and local. I think I'm trying to remember, so I wouldn't go into the detail here of how the color is made, but you can see here the brushes, the colors, and the full ingredients. I don't have it at the moment, but it's basically capturing the process of how the art is being created and creating an experience. What is being designed here by Leila Blaftain, she's a VR developer, are gaming experiences in which the general public could experience a walkthrough in these homes that are recreated in a realistic rendering of the home, and they can see the woman in these spaces actually creating the art. So recreating the process is mainly AI driven in understanding how the art was made and recreating it by the meta-human, these humanoids that could be embedded in virtual scenes. Language text, these are the last two examples just to wrap up. I'm very cognizant of the time. With language, we have BCI, so brain-computer interfaces capture the reading of people or children with and without dyslexia, reading Arabic script. It's more to raise awareness, or this exhibit would be an immersive experience so people understand how the brains are function differently and are different for people with and without dyslexia. So it basically projects images of the Arabic script and the brain activity using EEG headsets. So these are the BCI interfaces, and it's projected in the experience where users can understand the contrast between the brain activity. So it's more of to appreciate the difference between people with and without a dyslexia, and they hear the voices of the children as they're struggling with reading these Arabic scripts as they go through the installation. Now, in music and sound, I didn't want to elaborate here because of the limitation in time, but if I would highlight one aspect that would be relevant if you are integrating audio is the oral architecture. So think about how audio is presented to users in the virtual space, and this is what we refer to as oral architecture. Recommended reading is Spaces Speak, Are We Listening? It's published by MIT Press. It's very detailed and accurate description of spaces and how we can experience spaces indoor, outdoor, and how we can design virtual environments that emulate the experiences that we actually have, from cathedrals to home environments to public open spaces and natural habitats or in nature in the outdoors. I think with that, we have reached the end of the workshop. I thank you all for your attention.